So I want you to explain more about that multi-class support vector machine, sir.
Yeah, so as I've stated, so it's going to be part of our presentation for next week by the grace of Almighty God. So we're going to look into it in detail. However, just to give you a little hint of that is, see, when you have multi-class problem, support vector machine, in life, everything has its own advantage and disadvantage. So perhaps because it's only support that only 2 class, but the more the number of classes, the more the classification challenges you have. So support vector machine focus on drawing that unique separated hyperplane. Yeah, it's one of the machine learning algorithm that based on my experience with it, if somebody is writing a grant, it's very good to suggest it as one of the potential algorithm to be used, because in several cases we have used it, we always at least get something reasonable for us. However, we are not saying it is the best algorithm, because whenever anybody decides that this is the best algorithm in machine learning, that is an indirect declaration of ignorance about machine learning principle. So no algorithm is really better in all situations. However, support vector machine is very smart when it comes to these 2 class, because you just one class here, second class here, draw a line between it, expand the line, simple principle. Draw a line, expand that line until it meets one class in the right, one class in the left, and then you can stop. Or one sample from the right side, one sample from the left side. However, when you have 3 classes, then it becomes an issue. So let's say we have A, B, C. So you can't draw a line between, it's not the issue now. So in support vector machine, it uses the idea of 1 against all, 1 against all, or 1 against 1. So if you have like 3 classes, or let's say you have A, B, C, D, these are the 3 classes, class 1, class 2, class 3, class 4. Sometimes you can have many classes, it doesn't matter. So what the support vector machine does is, in 1 against all, it to pick A, separate it against all the others, 1 against others. So it try to see, all this one will be turned to like, they see it as if they are the same class. Assume B, C, D is the same class. See, in that case, A is the only class that we are separating against the others. All this one will be labeled as if they belong to the same class. This is the idea that it uses. So when you do that, then you are going to take B out again and do the same thing. 1 against others. C, 1 against others, until you solve the entire problem. However, the second implementation is 1 against 1, 1 against 1. In that case, you are going to take, assuming A versus B, you build a particular model for that. So B versus C, build it, A versus C, then C versus D, A, B, B, C, A, C, then C, D. So do a kind of combination among them to make sure that you have 2, 2, 2, 2 until you have the combination. So 1 against 1 or 1 against all. So we're going to show us, like I said, by the grace of God next week, pictorially how it works, and then some of the other details about it. So it has that capability. Then the idea is which one is better. Again, it depends on your data. Let the data speak. Sometimes you have 1 against all, while you have 1 against all. Sometimes you just let it select which of the 2 that might work for you. So this is just a summary of answer to your question. Like I said, we look forward to next week when we are going to discuss in detail different type of implementation for multi-class SVM and other special consideration that we might actually look into on SVM. Thank you very much, and I hope that's benefits a little.
Even though last week I said that when I was going through the literature and some of your papers, support vector machine, happen to be one of the most popular because of the attributes you've actually, identified. That is the capability to undo small sample and the like.
Yeah.
Now, when I, confronted the algorithm, some of these algorithm with the data I have, okay,
Yeah.
yeah, I have 28 attributes from the data, okay.
Yeah.
I have 28 attribute input data. I have 28 attribute input, variable, and the other one which is output variable 1. Now, from the I started with k nearest neighbor,
Good.
and I started with k nearest neighbor being as you advise.
Yeah.
Okay.
Simple one.
For
Yeah.
yes, I started with k nearest neighbor, and the performance, using the percentage split,
Yeah.
okay,
Yeah.
was not more than was around 60%.
Okay. That's a good start.
Using the whole features, 60%.
Yeah, that's a
I
good
then
start.
I then decided to do feature selections. I went for feature selections. When I went for feature selection, I observed that only 2 out of these 28 attributes,
Yeah.
out of the 28 features, were actually ascribed non-zero rank value.
Okay.
Only two. Now, when I did that, I decided to now take a quarter of the feature. I eliminated others. I just took a quarter because I can, it was surprising that only 2 were given. I did that.
Okay.
The performance, improved a little. I think it was maybe around 67.
Okay. Yeah.
Okay. And then, I now look at it. I now drop the last 2 to reduce, because out of 28 we have 7, right? A quarter, 7. Now I now reduce it to 5 by dropping the worst rank one. Okay. And the performance, increased to around 77.
Excellent.
Yes. And finally, I drop 1 to now have 4 features.
Okay.
I recorded around 82.9%.
Excellent. Okay.
Now, I now drop 1 again. When I dropped 1, there was a reversal in the performance.
Okay.
I now stop there. I return the one I drop again to maintain so that to determine the highest performance I can get from that.
Okay. That is called backward and forward elimination. Yeah. Okay.
Yeah. And I decided. Sorry, I'm taking much time. I then decided to look at parameter, optimization.
Okay.
Okay. I then, change the what is it called? The K. I think the K, right?
Yeah, K nearest neighbor. K, yeah.
Yes, I changed the K from 1 to 3.
Okay.
But there was no change in the performance.
Okay.
It had no effect on the performance. I stopped there.
Okay.
I stopped there and then decided to utilize other something. Now this one I'm reporting. Yeah. Okay, the one that gave best performance is cross validation, which is 82 0.9%. The percentage split gave lesser performance.
Okay.
Yeah. I also use this support vector machine, and support vector machine with the process I pass through, achieve something close to that of k-nearest neighbor, 82.1.
Okay.
Now I try out this random forest for ensemble, right?
Yeah.
Yeah, it achieved 81.3.
Okay.
Yeah. Now, my question now, going through the literature, I saw paper reporting mean absolute error, mean square error, root mean square error, with a view to comparing the performance of the algorithm. Yeah, but I noticed that we have there's no clear cut performance. Maybe I should not use okay. There's no clear cut advantage for a particular algorithm when you compare the mean absolute error root mean square.
Okay.
What I mean by this is that, for instance, for k-nearest neighbor with the highest level of accuracy, okay, the mean square error is 0.2892.
Okay, maybe let me just add there to maybe hopefully make this easier. Let me clarify a couple of things.
Okay.
This is a classification problem or regression problem?
Classification.
And if it is classification problem, then comparison should not be about mean, absolute error, and the likes. So for classification, maybe people have been doing it in some ways. You can maybe later offline, you can share the paper you are comparing with. If it is classification problem, we want to see the accuracy, which is the one you are telling us, good. And then we also want to see the confusion matrix. So which one has a positive or negative, false positive, false negative? These are the interpretation you are going to pay more attention to. Maybe people working on it in the past have been doing the wrong thing. We don't need to follow them. We have to establish a unique way of doing it.
Okay.
So we are going to focus on the classification, since it is a classification problem. Focus on the accuracy, then focus also on the confusion matrix, which is going to be below the solution. Why I deliberately allow you to continue this analysis, I want to believe it's like practical demonstration of what we have been teaching here, and I really appreciate that. So, and I hope others also will learn one or two things from what you have been saying, and also try pick up a problem. It doesn't have to be a real life data set. Pick up data set from all the data set sources we've listed. You can Google it. Just Google any data related to your interest and start doing something like this. You can see someone earlier also said he has been able to pick up a grant, we can do it actually. This is the essence of why I say machine learning for all. Irrespective of our background, we can do something. However, it is better done by engaging yourself practically. So pick up a problem. And that's why I really appreciate Professor Babalola, what he's giving us. So, however, I have a quick question for you, Professor Babalola. The two attributes that were initially ranked highest, did you ignore them, or what did you do to them? Did you run the experiment using them?
Yes.
What was the outcome?
It's a bit lesser than using 4, combining additional 2.
Okay, thank you very much. See, that's a very, very good indication. So sometimes some attributes as what we call co-relationship. There are some, in reality, sometimes when an individual work alone, it might work better, but when you put in with somebody with the same synergy, the two of them will achieve better results sometimes. So sometimes you have some features that having some information, but that information is not complete unless you combine it with another feature. That's why feature selection itself is a very big idea. So I want to believe with additional feature selection type, but at least pushing it from 60-something to 80-something, that is really a very unique. And being the first one to work on a very fresh data set, depending on the area of application, if it is not medical, even if it is medical, 80-something% accuracy. We will check the what do you call it? Confusion matrix. Confusion matrix depending on where the mistake are. If the mistake is on the higher side, then we have to work more on it. But if the mistake is from the less costly side, then we have to look at, okay, this is acceptable since mistakes are coming from areas that are not very problematic. For example, in medical, if the mistakes are coming from false negative. False negative means somebody is sick, but our system is predicting that he is not sick. That is a big mistake. We don't want it. Because that means somebody will go home and have complication because AI already clear him that he is negative, he is not sick. So such a mistake is very costly. However, false positive means somebody is not sick, but the system is saying he's sick. That is a mistake we don't want, but then it's less costly compared to the first case. So for this your problem, doctor, you have to establish, later we can discuss this, which of the classes is it false positive, which one is false negative, which one is less costly, which one is more costly, depending on what you are modeling. Should I give loan to someone? I should not give loan to someone. If the system says give loan to this person, even though he's not going to pay back, is it the costly option? Or it says don't give loan to him, even though it was a mistake, he could have paid it back. So you have to look at the background information, which one is more costly economically and customer relationship concern and host of other stuff. This is what you're going to use to establish the false positive and the false negative. So far, I think it's a success so far, actually. So from 60-something, even getting 60, I've seen someone actually who generate a new data set. And the best it could go is 45%. 45% after generating new data set. So it means the data set has issue, then we have to come up with an ensemble, very powerful ensemble, before they can push it to like 65 or 70. So for this kind of thing with the minors you have done, I think it's not doing bad. It's actually doing very good, actually. So I congratulate you for that, and I really appreciate your effort. However, also I will tell you, you need to, over that social learn. Once you start building a model, the first thing to check before you do feature selection is to do hyperparameter optimization. Because from your reporting, you started doing the feature selection you started doing the hyperparameter optimization after doing feature selection. So the moment you put all the data inside, you do hyperparameter. K, search for the value of K, then search for the value of the kind of distance measure you are going to use. It is when you know the result of post hyperparameter optimization, and now it's not yet satisfying you. Now you go for feature selection. Because feature selection is totally optional. So I hope that is clear. I wish you all the best, Doctor.
Okay, thank you, Prof.
Sincerely encourage each and every one of us to come up with a problem and try to solve that problem. By solving it, we know machine learning more and what to do and what not to do. Because sometimes theory is very easy until you go to the drawing board and try to do it. Then you run into some trouble. Then you can seek clarification, like our doctor has been doing since last week. So I deliberately allow him to take his time, so I know that others also will learn from what he is doing. Once again, thank you very much, and we look forward to other people also taking doing such a thing, and also sharing their experience with us in our weekly schedule. In fact, if anybody has some experience you want to share with us, let me know ahead of time. We can make our presentation to be very short so that we have enough time to make it. And if we have multiple people who want to share their experience, we can even declare a particular week meeting to be meant for that exclusively. Because to me, I'm more interested that everybody get really involved. I know some people are still afraid. Can I do it? Can I not do it? You can't do it. You can do it. That is my own personal belief and principle. I don't believe anything is impossible. So do it and then make the necessary efforts. Once again, thank you all for listening and for the participation. I wish you all the best. So